For this example, we've been asked to differentiate the function x squared plus y squared plus xy equal to 4. There is no way which we could rearrange this equation to find x as a function of y or y as a function of x. We therefore say there is an implicit relationship between the two variables. The question's asked us to differentiate to find dy by dx. So to do so, what we must do is differentiate both sides with respect to x. So I'm going to do d by dx of the left hand side, so that is x squared plus y squared plus xy. And as we know, what we do to the one side we must do to the other, so I'm also going to take the derivative of 4. Now 4 is a constant, and we know that when we differentiate a constant we get 0. So the right hand side of this equation is 0. So all I'm left to do is this derivative on the left. So I'm going to say the derivative of x squared plus y squared plus xy is going to be the same as the derivative of x squared plus the derivative of y squared plus the derivative of xy. And we now know that is equal to 0. So to differentiate x squared, we know from previous sections that x squared differentiates to 2x. But then we have to differentiate y squared with respect to x. So we should recall what we do here. If we're differentiating with respect to x, some function of y, and y is also a function of x, we do dg by dy multiplied by dy by dx. And that's our result for implicit differentiation. Basically, we differentiate the y with respect to y, so in this case it would become 2y, and then we just simply multiply by dy by dx. So it's going to end up being 2y times dy by dx. For the next term, we have to differentiate xy. Now xy is a product, so we're going to have to use the product rule. So you should recall that the product rule tells you that we'll differentiate the first term, leave the second one alone, and then we add to that, differentiate the second term, and multiply by the first term. So that's a reminder of our product rule as well. So differentiating xy, I'll differentiate the first term, so that will just give me 1. So that will become 1 times y. And then we differentiate the second term and leave the first term the same. So when we differentiate y, we're just going to end up with 1 times dy by dx, and then that's still multiplied by x. So bringing that all together, we see we have 2x plus 2y dy by dx plus y plus x dy by dx, and that is all equal to 0. Now we've been asked to find dy by dx, so what we need to do is rearrange this equation to actually find dy by dx. Just performing the differentiation and getting it down here isn't answering the question. So what we do, we get all the terms involving dy by dx on one side of the equation, and then we have everything else on the other side. So looking at this, we've got 2y dy by dx plus x dy by dx, the only two terms involving dy by dx, and so the 2x and the y have to be moved to the right hand side, and that will leave us with a minus 2x and a minus y. So what we should see now, if we take this left hand side, we can see that dy by dx is a common factor in both terms. So we're going to factorise that out. So we'll take out a dy by dx to leave us with a 2y plus an x in our bracket, and that is equal to minus 2x minus y. And then finally we can get dy by dx on its own by dividing by 2y plus x. So I can see dy by dx is equal to minus 2x minus y, all divided by 2y plus x. And that there is our final answer. That is dy by dx for this implied function here.